Hey guys, so we've learned about using a T table. We've learned about using a Z table, and they both make our heads explode at the beginning. However, now we're feeling great about it. So let's talk about how we can just totally forget the tables and just do it with the calculator. Wouldn't that be so much easier? A lot of you are probably thinking right now, Harper Smith, and wanting to strangle me because you wish I would have just taught you from the beginning how to do it with the calculator. But then you wouldn't understand what the calculator is doing, okay? So it's especially helpful with a T table when you're in between two values. So maybe you're like on this level, but you're looking for exactly one. And where does it fall exactly? I mean, you're looking for some of this stuff, okay? All right, so let's jump over to how to do it. Let's start with a Z test, okay? I'm just gonna show you Z tests for proportions and T tests for means. And I'm going to do it with a TI-84 calculator first. So we get our calculator, and you go to stats. Now this is a TI-83 or TI-84. They do the same thing. Now, once we're in statistics, we're doing a test. We're doing a Z test. So I need to go over to tests. Now, you might want to click Z test right off the bat. And if you do, it's going to bring up this. It's going to ask you for the average, standard deviation, your sample average, and the number of samples that you got. Well, if we're looking at here, we're doing a proportion. A proportion doesn't have an average. It doesn't have a standard deviation. It doesn't have a sample average, okay? So if you instantly click on Z test, it's going to take you to the wrong place because we're not doing a Z test. We're doing a one proportion Z test because there's one proportion in there. If you look, there's other ones. There's two sample Z tests. There's two proportion Z tests. The two proportion Z tests are my favorite. But anyway, we're going to do a one proportion Z test. You might want to write that down. One proportion Z test. One prop Z test. So we put in our first proportion. Well, the null hypothesis was it was 0.4. Okay. X. Our X is 15. And our N is 43. Ta-da! Now down here, it's got a couple different things going on, depending on if you want a one tail, two tail, or no tail test. Well, here, let me add a little bit here. If we're saying 15 and 43, 15 divided by 43 is 0.34. So let's say this is a one tail test. Next problem, we'll also say this one's a one tail test. Last one we'll do as a two tail test. Okay, so back up to the first problem. If it's a one tail test and we're thinking that's closer to 34%, not 40%, then our alternative hypothesis is going to be that we're actually less than the null, okay? So we're doing, this is for the alternative hypothesis. We're thinking that it should be less than whatever the null is. You can go to draw, I go to calculate, and it's going to pull up some numbers. And you know what it pulls up? It pulls up not only the z-score, it also pulls up the p-value for us right then and there. Bam, 0.2467. Okay, you can write that down if you want. If you have a p-value of 0.2467, are you going to reject the null? Probably not. Okay, you don't have enough data. And whether that's because it's too close to the actual mean or you just don't have enough samples, there's a couple different reasons why. But yeah, we don't have enough data to reject our null hypothesis. So we're going to keep the null hypothesis that the average really could be 40%. Let's try another one. I'm going to go to statistics. We're going over to tests. We're going down to a one proportion test because it's dealing with percentages. I'm just going to plug in the data. I've got a 0.2. What's 25 divided by 150? 25 divided by 150 is 16%. So 16% more than 20%, or is it less than 20%? It's less than 20%. So it's here, we've got 25, we've got 150. We're thinking that it's a one tail, so less than. We're going to leave that just like that. Click calculate. And we get a p-value of 0.15. Do we reject if we have a p-value of 0.15? No. Now, guys, this is a lot easier than going through, taking all these numbers, plugging them into the formula, solving the formula, then getting that z-score, plugging it into the z-table, then getting your p-value, then finally comparing. Oh, yeah, it's a whole lot easier, a million times easier. All right, last one. This is a two-tell. Then I'll show you how to do a t-test. All right, again, you go to statistics. We're going over to tests, going down to a one proportion test. This time, since it's a two-tell test, it's going to be not equal to, because it could either be greater than or it could be less than. We just care that it's not that answer. So we got 0.8, we've got 60, and we have 84. Now think, what does the N stand for? It's the number of samples that were collected. What does X stand for? The number of successful samples that were collected. All right, let's see if we keep or reject this one. We get a p-value of 0.049. More than likely, we would reject in this case. Very good. In this case, we probably would reject the null hypothesis that it's 80%. Now, it's telling us here that from our sample, our average was 71%. This doesn't mean that the average is 71%. All that this test says is that the average more than likely isn't 80%, okay? That's all that the test is saying. The test doesn't tell us what the actual average is. Okay, so that's how you do z-tests. Let's look at how to do a t-test with this calculator. Let's make this all a little bit bigger. Oops, so we can see it a little better. There we go. All righty. So I pull up my calculator. Now these are t-tests. Remember, a z-test for proportions, a t-test you would use on means or averages. You can also use a z-test for averages, but normally we just stick with the t-tests. Okay, so I'm going to go statistics, come over to tests. I'm going to do a t-test. Make sure that you are in statistics because we're putting in statistics. Now, if you just have a long line of data and you don't want to go through and figure out your averages and your standard deviations, you could just plug it all in to data and then work with it like that. But we're not. All right, our average, population average is 30. Our sample average was 34. The standard deviation of the average was, of the sample was 3, and that was based off of 28 samples. Now, sorry, again, I did forget to say whether or not this is going to be one-tail or two-tail. Let's do two-tail. Now the next ones we'll do one-tail. And one-tail again. All right, so here we go. I pull up my calculator. Which of these should I use if I'm thinking it's going to be a two-tail test? I'll use not equals, less than, or greater than. Remember, this is the alternative hypothesis I'm looking for. Well, we are thinking that the alternative hypothesis could be either greater than or less than, since it's a two-tail test. So we're going to go with not equal to. We go to calculate. We get a p-value of 0.000001. This is 7 standard deviations away from the mean. Remember, anything more than 2 is unusual. This is 7 standard deviations away from the mean. So in this case, we have some good evidence to support that the null hypothesis is not correct. We have some good evidence to support that it's not 30. Okay, so that's how you do the t-test. Let's try it with this one. 52 is obviously less than 60. So let's go to statistics. I'm going to come over to tests. We're doing a t-test, which is number 2. We're doing statistics. We've got 60. We have 52. We've got 5 and 8. Now I need to think. Is this a one-tail or a two-tail test? It's a one-tail. So it's going to be one of these two on the right. So either the middle one or the right one. Now I need to think, all right, is my alternative hypothesis that it is less than or that it is greater than 60? Well, is 52 less than 60 or is 52 more than 60? 52 is less than, so we're going to go with the middle one. I'm going to go to calculate. Let's see. we get a p-value of 0.001. Now, there isn't a set alpha here. However, generally speaking, if you have a p-value that's 0.001, you're going to reject the null hypothesis, okay? Reject it like it's the boy you don't want to go to prom with, okay? Say no. Alrighty, awesome. There's one problem left. Pause the video. Try this one on your own real quick. Okay, you should have paused the video. You should have had the answer on your own. Let's go through and do it. You go to statistics. We come over to tests. Go to t-test. Our average for the population is 130. We took a sample and we got 125 as our average with a standard deviation of 6 over the course of 180 trials. This is a one-tail test. 125 is less than 130. So we're going to stick with less than mu, not, and then click calculate. And we get a t-score of -11. So this is 11 standard deviations away from the average. Okay. If you're 11 standard deviations away, I mean, that's going to be like 0.00000000000000000. I'd be saying zeros all day long and then finally say 1 or 2 or 3, whatever. It's so far away that the calculator is just saying your p-value is 0. Basically, it's never, ever, ever going to happen. For instance, with human heights, so standard deviation. Let's see where that would put us. So the average height is 65 inches with a standard deviation of 3.5. So 65 inches plus 11 times 3.5. All right. So here, saying 11 standard deviations, for this, comparing that to human height, just making this reality, you would have to find somebody that's almost 9 feet tall if they were 11 standard deviations taller than average, okay? I'm 3 standard deviations taller than average. I'm tall. But if you want to find someone that's 11 standard deviations more than average, they would have to almost be 9 feet tall. It's like 8 point something, okay? So basically, this, not this one, sorry, this one. If you have this many trials, you reject the null hypothesis. Okay, you're rejecting the null. Cool. All right. There is a test. Good luck with it. We'll see you guys later.